Okay, an arithmetic sequence has a common difference. So you're adding the same thing to get from term to term. And that something could be negative. You could add a negative, right? So, all right, and a geometric sequence is going to have a common ratio instead. So that means we're going to be multiplying by the same thing to get from term to term, okay? So let's find the common ratio. It tells me that this is a geometric sequence. So I should be able to multiply by the same thing to get from term to term. Okay, and now, so 4 times something equals 14.8. Well, I don't know what that is off the top of my head, but hey, I should get the same ratio out every time. So I can write a little equation here. 4 times r is going to equal 14.8. Okay, and then I would divide both sides by 4. Okay, just as a little shortcut, you can always take any term, like the 14.8, and divide by the previous term. So 14.8 divided by 4 will give you the ratio, and that's what I got right here, right? So let's see, I'll put that in my calculator. 14.8 divided by 4 is 3.7. So here is my common ratio. And you can test it out too. If I take 4 times 3.7, that should give you 14.8, but then I can multiply by 3.7 again to get the third term, and so forth. I can test it going down the line, and it does produce those other terms. Okay, so there's 3.7. All right, so these numbers are getting smaller, but you can still multiply 100 by something to get 20. And you might think, well, can I just divide? Well, yeah, division is just multiplication. It's multiplying a reciprocal, right? Let's set up our little formula. I'm going to divide by 100. Okay, and then I'm going to get 1/5. This would be 2 over 10 if I reduced it, which would reduce into 1/5 or 0.2. Okay, so my ratio is 0.2. So yeah, it's dividing by 5, but dividing by 5 is the same as multiplying by 1/5, right? So my ratio is 0.2, and you could test it out right there as well. Okay, you can always just take any term and divide by the previous term. Okay. All right, so here is the geometric specific term formula. I use this to find specific terms in a geometric sequence. So I've got some familiar components here, hopefully. Whoops. This is the first term. And the new piece is the r. Well, that's just the ratio, right? And then the n is the term number. All right. So for this geometric sequence, we're supposed to find a sub 72. So I'm looking at this formula up here, and I'm just going to start plugging my bits in. All right, so I'm looking for a sub 72. I can see that the first term is 3. I need to find the ratio, and you can either just think what you're multiplying by. I'd be multiplying by 5 here, right, to get from term to term. Or you can do 15 divided by 3 if you like. Okay, so that's 5. And then the n is 72. So I've got 72 minus 1. Okay, so simplifying this, first thing I want to do is simplify the exponent. Okay, and the common mistake that gets made here is that people will say that, oh, this is going to be 15 to the 71st. Well, no, it's not. This is incorrect. Okay, that is the common mistake, because this is really 3 to the 1st times 5 to the 71st. So I have to simplify 5 to the 71st, then multiply by 3, okay? So I don't know what 5 to the 71st is, but my calculator does. So let's put that in. 5 to the 71st gives me that. Now notice, this says E49 at the end. So this is not 4.235. It's 4.235 times 10 to the 49th. This is a very large number, right? So this is in scientific notation. So this is this with the decimal move 49 places to the right, okay? So I'm definitely not going to write that in standard notation. I'm going to leave this in scientific notation, okay? So that's 5 to the 71st. I'm going to multiply that by 3, so it's going to get even larger. But I'm just going to leave this in scientific notation to make it, otherwise it's, I mean, my calculator can't even show me 50 decimals anyways. So I'm just going to say, I'm going to go 2 places past the decimal in general. So this is about 1.27 times 10 to the 50th. So that decimal is moved 50 spots to the right from there. Very large number. Okay, and once your calculator goes into scientific notation, I would just write your answer in scientific notation, at least for my class. Okay. All right. So let's try another. So looking for, I'm going to need my ratio, right? So I can take any term and divide by the previous term. So my ratio is going to be 1 divided by 5. Well, that's 0.2, right? Just like we had on that previous example, okay? So let's see. Using the same formula up here from the previous problem. So I'm not going to rewrite the formula, but I'm finding a sub 15. Okay, my first term is 5. The ratio is 0.2, or you could write it as 1/5 if you like. And then I've got n minus 1 up here, so 15 minus 1. Okay, so first I want to rewrite that as 0.2 to the 14th. Next, make sure you don't multiply that together. That'll just be 1 to the 14th, which is 1. And that's definitely not going to be the 15th term in this sequence, right? So simplify this first. 0.2 to the 14th. Okay, and then I will multiply that by 5. And this is in scientific notation, so heads up for that always on these problems. So this means the decimal is moved 10 spots to the left. So this is a very small number, which kind of makes sense because you can see these numbers are getting small pretty quickly, right? So I'll call this 8.19, roughly 8.19 times 10 to the negative 10th. So that would move that decimal to the left. So 0.0009 zeros after the decimal, then 819, the rest of it. Okay. Okay, on to the next page. Okay, so that was our specific term formula, and then for geometric series, we also have a sum formula. Okay, and here's what it looks like. Here is the formula. Okay, so for this geometric series, we're going to find the sum of the first 32 terms. You could build out all 32 terms and then add them all up, but let's try to use the formula, okay? So up here, I've got s sub 32. The first term, that's a sub 1. That's just 1, okay? And then I've got my fraction. So the ratio, I need to find the ratio. Well, that's pretty easy here. I'm multiplying by 2, right, to get from term to term. Okay, and then n is going to be the number of terms. That's the 32. And then 1 minus my ratio as my denominator. A lot of times I see people put a 32 there because that's what we did with the arithmetic sum. But this is the first term, not the number of terms. Okay. All right. So then I need to start simplifying this. I'm going to use my calculator to do this. Okay. So here's where you want to start. Start with 2 to the 32nd. This top part. Common mistake, people say, oh, 1 minus 2 is negative 1, so this is negative 1 to the 32nd. No, it's not. That is incorrect. Don't do that. So do the exponent before the subtraction, right? So let's see. I've got 2 to the 32nd. Okay, very large number. I'm going to do 1 minus that. Okay, so I would usually do most of this in my calculator, but since it's the first one, so my numerator is going to be, let's see, 5, all of that, okay? And the denominator, lucky for me, I don't need a calculator there, it's just negative 1, okay? So hey, that negative divided by a negative is positive, and then I'm multiplying by 1, so this is going to come out to 429,496. 7295. Put in some commas there. Yeah, so there we go. Large number. I'm glad I didn't do that by hand because it would have taken a while. It's surprising how large those numbers get that quickly, but it's moving exponentially, really, right? Because we're multiplying to get from term to term. Okay, so all right, let's try this one. S sub 10. So I'm taking the first term in this first slot, right? That's 2. 1 minus my ratio. And my ratio here, I'm going to be multiplying by 1/2, right? Because I'm dividing by 2. So, you could do 1 divided by 2. So I'm just going to call that 0.5. I'm going to write this as a decimal. Okay, and then n is my number of terms. That's 10 here. Okay, there's my setup. And again, I'm going to start with this in my calculator, 0.5 to the 10th. Okay, I've got this. I'll just leave that in my calculator. 1 minus that. Oh, and by the way, I'm using right above the negative symbol. I'm hitting second and then negative. And what that does is that uses my last answer. 1 minus my last answer. So I've got, this isn't scientific notation, so I wouldn't even want to try to type that out. But I can do 1 minus that last answer. Gives me this, which is almost 1. But I don't want to round it. Don't round as you go. Keep these decimals in there. Okay? And then so I was just saying don't round this, but this is about 0.999, but I want to use as much of that decimal as I can. Okay, in the denominator, I've got 1 minus 0.5. That would just be 0.5. So I'm not using 0.99, I'm using this whole thing, even though I wrote that on my paper. Okay, I'm taking this and dividing it by 0.5. Dividing by 1/2 is the same as multiplying by 2, so that should double what I had there. Yep, looks good. And then I'm going to double that again. And then I've got about 3.996. Okay. All right. So let's try the sum formula with sigma notation. Okay. So since it's off screen, I'll just write the formula again. So here it is. Okay. And sorry, I was flipping to the right page of my notes there. All right, so I need the first term. Okay, so let's build the first term. I'm going to get the first term by plugging in 1. So, hey, this is going to be the sum of the first 12 terms, right? So first term I'll get by plugging 1 in for k. Okay, so let's see, that's going to be negative 3 times 2 to the 0th. Well, 2 to the 0th, negative 3 times 2 to the 0th. 2 to the 0th is 1. So this is negative 3 times 1. So that means that this first term is negative 3. Okay? All right, first term is negative 3. I'll put that in that slot there. And then I'm thinking, what else do I need here? I know there's going to be 12 terms. That's my little exponent there. The other piece I need is the ratio. All right, so I can't see the ratio if I only know one term, so let's build a second term. So I'm going to plug in a 2 for k. Okay, so this will be 2 to the first. 2 to the first is just 2. And then 2 times negative 3 is negative 6. Okay, and this goes on. Of course, there's 12 terms, but I'm not going to build them all out because now I have enough to see that the ratio is going to be 2. Right? So that goes in that last slot. All right, I'm going to show you a little shortcut. But here's the thing, you have to be careful. You need the term builder to be in the right format. So if your variable in the term builder is k minus 1 or some variable minus 1, then what the base of the k minus 1 is going to be the ratio, right? This ends up being the ratio. Okay, and this will be the first term. Okay, because really this is in the same format as the term builder, the specific term formula for geometric sequences, right? So that shortcut is only going to work in this format. But if I'm in that format, then I don't actually have to build these out to see the first term in the ratio. Okay. And then from there on, I'm just using my calculator. So again, I'm starting there with 2 to the 12th. I'm going to do this whole 1 in my calculator. I'm doing 1 minus 2 to the 12th. So that gives me negative 4,095. That's the numerator, right? The denominator I can see is going to be negative 1, so I'll divide by negative 1. Okay, 4095, and the last thing is multiply by negative 3. And that's going to put me at negative 12,285. Okay. All right, next problem. I'm going to use that little shortcut that I just showed you because this is in the right format, right? I have k minus 1 as my exponent. Okay, so that means that this is going to be term 1, and this is going to be the ratio. So it's kind of nice when you know what to look for because these are pretty quick. You just plug them straight into the formula. So sum of the first 11 terms here. I've got the first term, which is negative 4, 1 minus the ratio. The ratio is 3, and then I'm raising that to the 11th because I've got 11 terms. Okay, and again in my calculator, I'm going to start right there and work my way out from there. Okay, clear that last stuff off there. 3 to the 11th. Got 1 minus that. So there's my numerator. I can see the denominator is going to be negative 2, so I'm going to divide by negative 2 and then multiply by negative 4. And that puts me at negative 354,292. Okay. Okay, and on to the next page. Okay, so we're going to look at, well, here's the geometric specific term formula from earlier in the section. Okay, we're going to use that in this next problem where we're going to rewrite this series in sigma notation. So there's my uppercase sigma, right? So, what I want to do here is use the specific term builder formula in this position, okay? So over here, I'm going to use the specific term formula. Okay, so before we get to that though, I want to always start, it's easier, you can start by plugging something else in, but it's easiest if you start by plugging in a 1 for k into your specific formula, okay? And then to figure out how far this is going to go, I just count up the amount of terms, 1, 2, 3, 4, 5. There's 5 terms, so I'm going to plug in 5 different things into my formula, so I'm just going to put a 5 up there, okay? And now what I'm going to do here, I'll just use, okay, my first term is 3. All right, the ratio, well, I have to look at this a little bit, but hey, these are doubling from term to term. So my ratio is 2. Okay, and then I've got n minus 1. And n is the number of terms. So actually, I don't want to put n in, the number of terms in. I want my k in that position so that I can build my terms. Okay, so I'm using this. I use k. I guess you could use n's here for any variable, but I used k's. And yeah, I just plugged in the first term, the ratio, and then left that as k minus 1. And you can try it out, right? You could plug in 1 for k. Let's see, 3 times 2 to the 0th. 2 to the 0 is 1, times 3 is 3. That works, right? And if I put in a 2 here, 2 times 1, 2 to the first is 2. And then multiply that by 3, I get 6. It works out, right? So this is the sigma notation of that same sequence. Okay, let's try another one out. Okay, I'll leave that formula up there because we're going to use that. All right, so I'm counting up the terms again. I've got 4 of them here, so I'm going to plug 4 different things in. Okay, The first term is 4, so that's going to go in this position. And then I've got, hang on. This is not exactly a trick, but this is not a geometric sequence, right? We're adding something to get from term to term. So I tricked myself a little bit, okay? So I can't use geometric specific term formula. I've got to use the arithmetic one, okay? The arithmetic specific term formula is as follows. Okay, so I'm going to use this formula. I'm just going to use that piece of it to build my terms, okay? So my first term actually does go there still. So let me scratch that out because I didn't want the parentheses, okay? But then I'm going to put in my difference in that second slot, all right? And then instead of n, I've got k down here, minus 1, okay? And it's probably a good idea to clean this up a little bit because we can simplify that. So I'm going to distribute the 3. Here, so I'll just work on this piece for a second. This will be, so I don't have to keep writing the sigma piece. 3k minus 3, and then I combine the like terms. 4 and negative 3 gives me 1. Okay, so that simplifies the 3k plus 1. So let's write the whole thing now. Okay, and there we go. And again, you could test this out by trying to build your different terms.